Welcome to Sine and Cosine, the functions, part 1. In this section, we'll be looking at the graphs of the sine and cosine functions, transformations of the graphs, and using a TI-84 calculator to graph these functions. Let's start with the graphs of sine and cosine. A function f is a periodic function if for every real number x in the domain of f, and for some positive real number p, f of x equals f of x plus p. What this means is, if you shift a period p to the right or left, you have exactly the same function over again. So if we have some periodic function, a function that repeats itself, and we were to take another function and shift it over, we would still have that same shape again. The functions sine and cosine have periods 2 pi. So if you add or subtract 2 pi from the period or from x, as in our formula, this means the sine and cosine functions are periodic. And if you were to add or subtract 2 pi, you would have the exact same function again. If you look at the statement here, this shows this idea. For sine of theta plus 2 pi, if you were to shift over 2 pi, you would have the exact same thing again. And this is also true for cosine. Cosine of theta plus 2 pi is still equal to cosine theta. Consider a unit circle and look at how the sine and cosine functions change. Keep in mind that a point on the unit circle has coordinates cosine theta, sine theta. Remember, cosine theta is like your x and sine theta is like your y. In quadrant 1, we go from an angle of 0 to an angle of pi over 2. And when we look at the sine of that angle, we go from 0 to 1. And if we looked at cosine, we could see that we go from 1, and as we curve around, we get closer and closer to 0. So we go from 1 to 0. Now let's look at the interval from pi over 2 to pi. On this interval, we go from 1 to 0 in the y direction, so going downwards as we get closer and closer to pi. And if we think about this in the x direction, we are getting closer and closer to -1. So we're going from 0 to -1. Next, let's look at the third quadrant. In the third quadrant, we're going from pi to 3 pi over 2. In the y direction, we're going from 0 to -1. In the x direction, as we rotate from pi to 3 pi over 2, we're getting closer and closer to 0. Remember, we're looking at the x direction for cosine. So from -1 to 0. And in the fourth quadrant, we're going from 3 pi over 2 to 2 pi, In the y direction, we're going back to 0. And in the x direction, we are going to 1. If you wanted to list the domain for sine of theta, that would be all real numbers. And the domain for cosine of theta would also be all real numbers. The range for both is also a high point of 1 and a low point of -1. So we would go from smallest to largest in interval notation, including the low and the high point. So the range is -1 to 1 for both sine and cosine. It's important to note that it's traditional to use the letter x to denote the variable in the domain of a function. So from here on, we'll write y equals sine of x and y equals cosine of x, and so on, to denote trig functions. But keep in mind that the sine of theta is basically keeping track of how high you're going around the unit circle, high or low, and cosine of theta is keeping track of how far left or right you would go around a unit circle. So we're kind of mixing the two together, but I think as you practice these, you'll see the context for which one can be used more appropriately than the other.